Ankita, Ankita Kumari,
Yes, sir.
have you done the numerical? I have given the numerical in the slide that is mentioned. Ramp sequence is power signal or energy signal? What is it? Anybody? Anybody else? I told you the solution to upload in the message box. None of you have done it, has done it. That means you are not taking things seriously. How you will calculate? What is the process? Anybody please respond? Is my slide? Okay. So you are not attending, listening the class seriously, taking the class seriously. So now you see that we have discussed some properties of discrete time signal. Okay, now we'll see on another topic, that is difference equation. Okay, you see in this slide the topmost equation, actually it is yn plus a1 yn minus 1 plus an y small n minus capital N, that is equal to b0 xn plus b1 xn minus 1 plus bm xn minus m. Okay. So this represents actually sum of delayed versions of input and output. Delayed version is yn minus 1, y2, yn minus 2, like that. And similarly, the delayed version of input xn is xn minus 1 and this. And they are having some weights. Weights is for output a1, a2 till an, and for input weight is b0, b1 to bm. Okay. Now, this is can be represented as yn, taking the present term yn, separating the present term out, and then sum of weighted version of delayed output y, that is sum of ai into yn minus I, that is equal to sum of I is equal to 0 to m and bi xn minus I. So here includes the present and past inputs of that is x. So this whole equation represents one difference equation. In continuous domain, this actually represented as dy dx, and in discrete domain it is sum. Okay, so now in this equation, if you take the delayed version of output to the right hand side, you will get yn is equal to minus of summation ai yn minus I plus I is equal to 0 to m bi xn minus I. So this actually called, it is also as the property of recursion. Okay, that is recursive. Output is fed back and delayed and added with input. So this is written that current output to be computed. This part is past output values and this is current and past input values. So this is one difference equation of nth order. N order because the delay of output goes till n. Now let us take one representation of difference equation, that yn is equal to 0.25 yn minus 1 plus 0.5 xn plus 0.5 x of n minus 1. Okay, so this how will represent, we use one stage that is the delay stage, Z inverse. We will explain why it is Z inverse. Okay, later you will understand why when you put the stage Z inverse, that means some delay occurs. Delay by 1 unit of sample. So xn is your input. Now after passing through it, it becomes xn minus 1 and some scaling is there, scaling of 0.5. Then they are added. So it becomes xn plus 0.5 into xn plus xn minus 1. Okay, this part is over. Now this is output yn is delayed. Okay, yn, and it is delayed and scaled by 0.25. So both this and this part is added and you will get the output, final output yn. Okay. So this is the simple representation of recursive system or difference equation. Okay. Output is fed back. When the output is fed back, feedback is there, then it is called recursive. Okay. Now there are some classification of discrete time systems. First classification is static versus dynamic system. Do you have any idea about static and dynamic systems? Don't leave, Abhinav. I will not ask you. I can see Yusovar is leaving. That means they are afraid of getting the questions. स्टैटिक सिस्टम क्या है, डायनामिक क्या है, बताओ। अक्षय, 1600 अक्षय, शौनक, Shaunak, are you there? Shashwat?
यस सर। सर आवाज आ रहा सर?
हाँ आवाज आ रहा है।
यस सर।
स्टैटिक सिस्टम क्या है बताओ, व्हाट डू यू मीन बाय स्टैटिक सिस्टम?
सर स्टैटिक सिस्टम का मतलब है सर कि सिर्फ प्रेजेंट इनपुट पे डिपेंड करेगा सर, उसको पास्ट से कोई लेना देना नहीं है। कॉम्बिनेशनल सर्किट टाइप सर, मतलब जो इलेक्ट्रॉनिक्स में पढ़ते हैं वैसा टाइप सर।
Yes, static system is memoryless.
यस सर, मेमोरी लेस सर।
And the opposite is dynamic system, which has
यस
memory. Okay?
यस सर।
So now you can see, okay, thank you, Shashwat. So
यस
you can see that some examples in the slide, dynamic system, a static system and dynamic system examples. The output yn is purely dependent on present value of xn, no past values. So n and n, no n minus 1, no n plus 1. Okay. But here in dynamic system, output depends only on past and present values of inputs. So n minus 1, okay, n minus 1, 2, n minus 3, n minus 4, up to n minus infinity kind of thing. But here you see that no n plus term is there. That means output does not depend on n plus 1 future values. Okay? N plus 1 or n plus 2, that means that it is future values. So it is not dynamic system. Output of dynamic system is not dependent on future values of input. It is only dependent on past and present values of input. एंड अगर ये फ्यूचर में डिपेंड करेगा सो कौन सा सिस्टम होगा? अच्छा ये हम बाद में बताएंगे, अभी देखो नेक्स्ट कैटेगरी इज टाइम इनवेरिएंट एंड टाइम वेरिएंट सिस्टम. सो स्टैटिक एंड डायनामिक क्लियर हो गया. स्टैटिक में इनपुट प्रेजेंट आउटपुट प्रेजेंट इनपुट के ऊपर डिपेंड करता है और डायनामिक में प्रेजेंट इनपुट एंड पास्ट इनपुट, xn and xn minus 1, xn minus 2, like that. Then another category is time invariant and versus time variant. कोई बता सकते हो क्या है? What is the meaning of it? You have studied earlier. ये डिस्कस करते करते क्लियर हो जाएगा आइडिया, हमको बताने का जरूरत नहीं पड़ेगा. कौन बताएगा? Who will tell? परवेज, परवेज है? शाहिल, परवेज, फारूक, anybody is there?
यस सर।
हाँ बताओ. ये जो हम पूछे हैं अभी, टाइम वेरिएंट और टाइम इनवेरिएंट मतलब क्या है? पता नहीं है, किसी को पता है? Does anybody know? गर्भ गर्भ कुमार खंडेलवाल, आर यू देयर?
Yes, sir.
हाँ बताओ, टाइम इनवेरिएंट और टाइम इनवेरिएंट क्या है? What do you mean by time variant and time invariant system? Shangam Kumar. Okay, you can see in the slide that time variant and time invariant means for the system whose output does not change if the input is applied at any time. Input. So see, say if today I apply one input to one system and we get some output, then if the same input is applied tomorrow, then if the same output is obtained, then it is called time invariant. That means time के साथ vary नहीं करता है out response, but time variant में time के साथ output vary करेगा. So यहाँ पे एक notation है, you can see that you have to know the symbolic representation in the signal processing techniques. So y x of n minus k. Suppose xn is given to one system, operation tau is the operator, then output you get yn. Then same system out operator is tau. Then if the input is delayed, so output should also be delayed and be same. Okay, be delayed yn n minus k. So if it is true, if this yn and yn minus k are same, then it is called time invariant. So there are some examples. Okay, you must solve these examples. Time variant, like one example is x of n x of n minus x n minus 1. Okay, so whether it is time, it is actually a differentiator. Okay, so difference between two samples. So this is actually time invariant. You see, the system is time invariant. Just go through the calculation. Okay, then some examples of notation of some symbols that you can see, that xn and n, it is multiplied, that will give you n of xn. Yn is folded, it is folded, so it is x of minus n, like that. Then xn it is multiplied with cos omega zeta 0 n, so it is called modulator. Okay. So now another classification is linear versus non-linear system. So you can see in the slide that linear and non-linear. Non-linear system means what? It follows which principle? Can anybody tell? Linear system follows which principle? Shashank? Shashank Shekhar? Do you know or you don't know?
Hello.
Yes.
Yes, sir.
What do you mean by linear system, Shashank?
Sir, linear system obeys principle of superposition.
Yes, principle of which follows the principle of superposition. Correct. That means what? That suppose we apply one input, okay, x1n, and another input x2n, okay, and we apply it individually to the system. When we apply x1n, that time we get output y1n. When we apply input x2n, that time we get output y2n. Okay. Now, if both the inputs are simultaneously applied, that means now the input say is x1n plus x2n, both are added, x1n plus x2n. Then output we have earlier calculated individually, that yn plus yn and y2. Now when the inputs are added, that time if the output also if get added, then we call it linear system. Okay. So output would be y1n plus y2n. This is the criteria. And now say if you apply some weight to the input, okay, say it is a1 and a2, so output should also be scaled. Okay. So output applying the weight to the input x1n, a1 x1n, and their combined input, that is a1 x1n plus a2 x2n, output should be sum of the outputs due to the individual weighted inputs. That means individual outputs is operation, this t operation on x1n, that is say it is y1n plus y2n. That means a1 y1n plus a2 y2n. Okay. So this is the description. You might know these basic definitions of linear and nonlinear system. So just we are revising those. So I am not explaining in detail. Okay. Just go through these slides, you can understand it easily. And there are some examples, okay, that determine if the system described by the following input-output equations are linear or non-linear. So n of xn, x of n square, Okay, x square n, many examples are there. You just go through it. Okay, so that first the solution for the first example, that is n of xn. Okay, they have calculated. They have taken two inputs x1n and x2n. So individually two outputs we get y1n and y2n. And if the inputs are simultaneously applied, combined input, so input is now this one, a1 x1n plus a2 x2n. Okay, and they are multiplied with n, so n comes at the output. So this is also the sum of y1n plus y2n, two outputs. So that means it is actually linear. Okay, this is linear. Similarly, go through xn square. Can anybody tell x of n square is linear or non-linear? X of n square. And x square n, which one is linear and which one is non-linear? Can anybody tell? X n square and x square n. That is x of n square, one case, and another case is x square n. Which one is linear, which one is non-linear? Can anybody tell? Prahlad,
Yes, sir. Yes,
x
sir.
एक्स स्क्वायर एन लीनियर है कि नॉन लीनियर है, कोई आइडिया?
सर x ऑफ n स्क्वायर सर लीनियर है।
और एक्स स्क्वायर एन
सर आइडिया नहीं है सर उसका।
आइडिया नहीं है। एक्स ऑफ एन स्क्वायर इज लीनियर, ये करेक्ट है। एक्स स्क्वायर एन, ये तो ऐसे कोई भी बता सकता है आउटपुट वाई एन इज इक्वल टू एक्स स्क्वायर एन। ये क्या लीनियर इक्वेशन है कि नॉन लीनियर इक्वेशन? डोंट गो फॉर द मैथमेटिकल डिटेल, जस्ट फ्रॉम योर concept you can tell the answers. लीनियर है जो स्ट्रेट लाइन फॉलो करता है, स्ट्रेट लाइन इक्वेशन, स्ट्रेट लाइन का इक्वेशन। नॉन लीनियर है तो क्वाड्रेटिक अगर है तो ये नॉन लीनियर होगा, क्वाड्रेटिक इक्वेशन। तो एक्स स्क्वायर एन क्या होगा? ये क्वाड्रेटिक है, एक्स स्क्वायर स्क्वायर टर्म है, तो क्या होगा? लीनियर होगा कि नॉन लीनियर होगा? बताओ। इस तरह से कोई क्लास चलता है? न तुम लोगों को मजा आएगा, ना हमको मजा आएगा। सब सो रहा है। खाना वाना खा के सो गए लग रहा है सब। बहुत नींद आ रहा है अभी। डायलॉग है, याद है ना, चैन से सोना है तो जग जाओ। चैन से सोने का टाइम अभी नहीं है, चैन से सोने का अभी टाइम नहीं है, बाद में आएगा। अभी जगे रहना है। So x square n is a non-linear system. Okay. So causal and non-causal system. Okay. Causal and non-causal. Causal system is what? Output of the system at any time depends only on present and past inputs. That is called causal system. But does not depend on future inputs. That is xn plus 1, xn plus 2. Okay, these are the future inputs. Future क्यों है? क्योंकि अगर प्रेजेंट में अगर हम है n is equal to 0, let us say the present time we are considering n is equal to 0. So यहाँ पे n is equal to 0 बैठाएंगे, so ये क्या होगा? x of 1, x of 2 मतलब फ्यूचर हो गया, या कोई भी प्रेजेंट टाइम हो, let us say n is equal to 5. There is the present time we consider n is equal to 5. So future past present time होगा x of 5, x of 5 minus 1, ये पास्ट हो जाएगा मतलब x of 4, then x of 3. ये सब सैंपल्स चला गया है, ठीक है, पास्ट है. और फ्यूचर में क्या है कि ये सब फ्यूचर इनपुट बाद में आएगा फ्यूचर में. ठीक है, ऑलरेडी हम n is equal to 5 में है, प्रेजेंट में है, उसके पहले जो भी इनपुट्स था दोज आर ऑल पास्ट. अब उसके बाद जो टाइम में, उसके बाद वाला टाइम में जो वैल्यू आएगा, दिस आर ऑल फ्यूचर. सो n x of 6, x of 7, these are all future inputs. So causal system in present and past inputs, x of n, x of n minus 1, x of n minus 2, but does not depend on future inputs, that is xn plus 1, xn plus 2. Okay. So mathematically इसको ऐसे लिखते हैं. Now if a system does not satisfy this condition, then it is called non-causal. Such a system has an output that depends not only on the present and past inputs but also on future inputs. ये important line है. ठीक है, अभी देखो, अभी कुछ एग्जाम्पल्स है causal and non-causal का, like x of n minus xn minus 1. ये causal है कि non-causal? y of n that is equal to x of n minus x of n minus 1. Is it causal or non-causal?
causal,
Causal, क्योंकि प्रेजेंट और पास्ट इनपुट. x of n plus 3 xn plus 4, ये कौन सा है?
non-causal,
Non-causal. तो ये सब एग्जाम्पल्स ठीक से देख लेना, आइडिया क्लियर हो जाएगा। अब और एक कैटेगरी है, टोटल 5 कैटेगरी है, ABCDE यहाँ पे लिखा हुआ है। नाउ लास्ट कैटेगरी इज स्टेबल वर्सेस अनस्टेबल सिस्टम। स्टेबल सिस्टम मतलब है कि उसका आउटपुट हमेशा एक फाइनाइट रेंज में रहेगा, बहुत ज्यादा हाई नहीं हो जाएगा। इट शुड नॉट बी वेरी वेरी हाई और इट शुड नॉट बी इन्फिनिटी। दैट सिस्टम इज कॉल्ड स्टेबल सिस्टम। An unstable system means whose output becomes very very high or infinite. Okay, that is called unstable simply. But mathematically क्या बोलते हैं कि it is also called Vibo stability. Vibo stability means bounded input, bounded output. Bounded input means small input. Okay? Small input, limited input, limited input. अगर इनपुट स्मॉल देते हैं तो आउटपुट भी लिमिटेड मिलना चाहिए, बाउंडेड होना चाहिए। और अगर इनपुट स्मॉल दे रहे हैं, आउटपुट अगर बहुत ज्यादा मिल जाएगा, अनबाउंडेड हो जाएगा, एक्सट्रीमली हाई और इनफाइनाइट हो जाएगा, then that time that system would not be called stable system. It is called in unstable system. Okay, so यहाँ पे देखो, यहाँ पे let us say input is xn and output is yn, and their value say is mod of xn is less than some value, say mx, magnitude of x. mx is magnitude of x. Okay, so उससे भी कम है, mx तो फाइनाइट होगा, मतलब लेस देन इंफिनिटी, दैट इंडिकेट्स दैट मैथमेटिकली इट इज फाइनाइट वैल्यू। और ये एक फाइनाइट वैल्यू है और इनपुट xn है, उससे भी कम या सेम, ठीक है, उससे भी कम है और सेम है, दैट इज कॉल्ड बाउंडेड इनपुट. सो दिस काइंड ऑफ इनपुट इज अप्लाइड, देन आउटपुट क्या होगा, वो भी बाउंडेड होना चाहिए. से लेटेस्ट से आउटपुट इज generated having magnitude my, m for magnitude, my, and it is less than finite, and output should not be more than that. Output yn, magnitude of yn should not be more than that defined limit. So that is called Vibo stable system. Okay, so one examples we have one example, say yn is equal to y square n minus 1 plus xn. so यहाँ पे क्या करते हैं, ये देखा गया, यहाँ पे कैलकुलेशन करके देखा गया कि ये इट इज नॉट स्टेबल सिस्टम, इट इज अनस्टेबल और विबो अनस्टेबल सिस्टम. ये थोड़ा मैथमेटिक्स पढ़ लेना, उसका जो कैलकुलेशन है क्लियरली अंडरस्टैंड कर सकते हो इसको. इसमें वो जो डेफिनेशन है उसके अकॉर्डिंगली yn कैलकुलेट कर दिया है. ये c टू द पावर 2n है, c का पावर आ गया, c का पावर आ गया मतलब n अगर सर्टेन टाइम इंस्टेंट n के ऊपर डिपेंड करेगा, c से 100 टाइम इंस्टेंट, सो c इंटू टू टू द पावर 100 200, तो बहुत ज़्यादा हो जाएगा. कि c अगर 1 से ज़्यादा है, c अगर 1 से ज़्यादा है, ठीक है, तो बहुत ज़्यादा हो जाएगा, इन्फिनिटी मतलब बहुत ही हाई हो जाएगा, तो ये अनस्टेबल हो जाएगा. ये इसका लॉजिक है. ठीक है, आज के लिए हो गया क्लास। तुम लोगों का क्लास लेना बहुत, आई एम फाइंडिंग वेरी मच डिफिकल्टी। Already very few people have joined, very few people are attending. I'm not getting any interest. Although still few people are responding, but others are useless totally. Those who are not responding are useless. ठीक है, जाओ वो टाइम हो गया, अभी जा सकते।